If f of x is equal to following expression, for what integers n and m does both of this limit exist? So we have the question that we have f of x, the limit existing at x is equal to 0. So what should be the value of n and m so that this condition is satisfied? That's the question. So all we have to do is approach it from left hand side, and from the right hand side equate those and try to figure out the answer. So we have this to be limit, so this is mx square plus n, a limit, so we have this to be m plus nx. Let me not confuse you guys. Nx plus m. Just take a second and check it's correct, right? When we are approaching from the left, we have this expression. On the right, it's this expression. Okay, I hope that is clear. And on substitution, we will get n is equal to m. Because this is 0 and this expression is 0, so n is equal to m. Now I'll write the final answer later. So for the next case, x tending towards 1, if this exists, then what do we have? We have limit f of x as x tends to a minus, and we have the plus 2. So what can we conclude? We can tell that limit on the left hand side we have it to be nx plus m as x tends to this, and we have nx cube plus m. So all we have to do is substitute. So this is n plus m is equal to n plus m. What can we conclude now? So what is your conclusion? That is more important. All this is okay. What is your conclusion? Think of it. So for what condition will the limit exist at 0 and at 1? Right? So the first one is for limit x tending to 0 f of x exist when n is equal to m, and we have for limit f of x as x tends to 1 exist when we have here what is happening? Here n plus n is equal to n plus n. What does it mean? We can put any value for all or for any integer value, right? Yeah. Of n and m. Okay, because end of it you will get 2 plus 3 is equal to 2 plus 3. You put any integer value, minus 10 plus 4, minus 10 plus 4. By default, we'll get the same expression on the LHS and on the RHS. So it doesn't matter what value of n and m we have, we end up with it being continuous at 1. But at 0, the condition is that n has to be equal to m. Right, that's what we got over here, and that's your conclusion.